RealSprint's vision for Vindral, its live streaming CDN, is to deliver the quality of HLS and the latency of WebRTC. Early trials revealed that CPU-only transcoding lacked scalability, and GPUs used excessive power and proved challenging to configure. Implementing NETINT's ASIC-based Quadra delivered the required quality and latency in a low-power, simple-to-configure package with H.264, HEVC, and AV1 output. As a result, Quadra became a preferred component of the Vindral setup, and the RealSprint implementation can potentially become a blueprint for any company looking to add low latency H.264, HEVC, or AV1 transcoding to their product or service. Vindral is the ultimate solution when a desired latency is around 1 second and where stability is imperative, even at high video quality. But Jan, who needs low latency?
There's a couple of markets that need low latency. When you talk about WebRTC, you're talking about truly interactive, conversations and similar communications that really need they can't exist comfortably at more than a frame or two latency. The next level are the types of activities that Vindral is targeting, and that typically is, sports, some gaming, and auctioning, where you really need people at the facility and people online at a common point in the video in order to keep the bidding fair. So those are the types of 1 second latency that I think Vindral is targeting.
Cost per stream, power, output quality, format support, latency, and density, those were the criteria that RealSprint considered when exploring its transcoder options. They started with CPU, moved on to GPU, and what happened? It didn't work?
In speaking to RealSprint CTO, we learned the obvious: CPU-based transcoding doesn't work for high-volume interactive applications. It's just too much CPU, too high cost, too much power consumption. We also learned that they found GPUs hard to work with, and also that they drew too much power as well.
Vindral implemented Quadra Video Processing Unit over T408, a video transcoder. Why?
So the simple answer is AV1. The T408s are based upon our first generation technology. They output H.264 and HEVC. RealSprint wanted AV1 as well because they think that's the next big codec, and there's a lot of data that backs that up. The other thing, Quadra is a later generation. There are many things about it that T408s don't have. The quality is scalable. So if you want really, really good quality, you can pump that up within the transcoder, and you lose a little bit of throughput. On the other hand, if you want maximum throughput, you get the quality down in the normal range, and you get both. In addition, it's got onboard scaling and onboard overlay. So if you have productions that involve those, you're producing encoding ladders, or you're putting a bug over your video, then you can configure a system that's got lower CPU because all that's being handled on the Quadra itself. So overall, Quadra is a very, very economical product, pretty much the same cost per stream as the T408, but a lot more capabilities and a lot more features.
ASICs are unmatched in terms of the number of streams per rack unit. That translates into density and power consumption. But why does it matter?
Density refers to the number of units you can put into a server. And the more density, the fewer servers you need. And the fewer servers, the less storage costs you have for those servers, and the less power cost. And I love Daniel's quotes about power. He talks about the bill you get today, but also the bill that you're leaving your children. And if you're not concerned about power consumption today and the associated carbon footprint, then you're just not paying attention.
Talk about linear loads, or specifically a predictable linear load pattern. Per Mafrost, RealSprint CTO considers that a primary differentiator between NETINT ASICs and many CPUs and GPUs. Why?
Linear load refers to the ability to count on the system to be able to produce a certain amount of throughput. So if you have a CPU-based transcoding facility, for example, you typically never want to go beyond 60 or 70% of CPU, because spikes in CPU utilization could stop the stream. So say you spike up to 100, the stream stops. You either have a delay or the system breaks and you have to reboot and start over. So linear load on a GPU means the same type of variation. And what a lot of our customers find with our cards is that it's got a very consistent linear load, which means, if you're going to produce X streams from a card at 85%, you can run it at 85% because it's not going to spike up to 100. With the GPU, you can't do that. And with the CPU, you certainly can't do that. If you get above 60 or 70%, you really have to worry about the system crashing.
Google launched their own encoding ASIC-based transcoder called Argos, as did Meta in 2022. But those are only meant for internal use. At NETINT, we make ASIC-based transcoding available to everyone. Is ASIC-based transcoding only viable for new companies?
I think it's always easier to sell into companies who are, initially building up their infrastructure, but we see a lot of customers who are expanding their capabilities. And we see some customers, particularly in Europe, where power prices are getting much, much higher, who are considering, if not already, switching out to ASIC-based transcoders because you can recoup the cost of that investment in 2 or 3 years, if not less, by power savings alone. And we've got a calculator on our website that helps you calculate both the number of T408s necessary to produce the streams you currently need, and also the payback period on those T408s.